I'm just going to put exact values for 30 degrees, 45 degrees, 60 degrees, trig ratios of these. It's not, so I'm going to be looking at sine 30, sine 45, sine 60, etc. So, exact values for these special numbers, 30 degrees, 45 degrees, and 60 degrees. These numbers come from triangles. I'm going to start off with a right-angled isosceles triangle, and the two equal sides are 1 unit. Okay? Now, if this is a right-angled triangle and it's isosceles, 2 equal sides, there must be 2 equal angles. Does anyone know the sizes of these angles? All right, so I'm going to write them in. And can anyone tell me how to work out this side length here? Right-angled triangle. See, with right-angled triangles, girls, you can do one of two things. You can do sine, cos, tan, so you can use trigonometry in a right-angled triangle. The other thing you can do in a right-angled triangle is use Pythagoras' theorem. So there's only 2 things you can do. So if I want this side length here, I'm going to use Pythagoras' theorem. That's the hypotenuse. So I'll just call it x for now, or so x squared equals, what do we do? 1 squared plus 1 squared. So x squared equals 2. So therefore x equals the square root of 2. Girls, this is all about exact values. I'm going to keep that answer exact. So this is what I've got. I've got this right angle triangle, side length. The equal sides are 1. So we've got 1, 1, and this side length here is root 2. And these two angles are 45 degrees. So I'm not going to touch that triangle anymore. I'm just going to draw it here. Again, I've got 1, 1, root 2, and I'm just going to put one of the angles down there. I'm not going to put both of them down there. In this triangle, I'm going to be doing ratios for 45 degrees. You know how I said today we're doing trig ratios for 30 degrees, 45 degrees, 60 degrees? This triangle with 1, 1, root 2 only allows me to do the 45 degree exact values. So let's start with sine. Sine of 45 degrees. Isn't that opposite over hypotenuse, which is what? 1 over root 2. Good. Cos of 45 degrees. So, sine of 45 degrees is opposite over hypotenuse, 1 on root 2. Cos of 45 degrees is adjacent over hypotenuse, 1 over root 2. So, girls, those two are the same. And which one have I missed? Tan of 45 degrees is, what's the ratio? Opposite over adjacent, TOA, 1 over 1, which is 1. So, girls, they're the exact value ratios for sine 45, cos 45, and tan 45. So you can either learn these off by heart, which we do recommend that you do, because in the exam you need to know them quite quickly, all right? But the other thing you can do is work them all out on your calculator. Now do the tan 45 first. Make sure your calculator is in degrees mode. Tan 45 equals 1. Good. Okay. So that one you don't need to square it. You only square it if you get a horrible answer. So tan 45 you can do on your calculator, it's 1. Now do sine 45 on your calculator and you'll get 0.707, whatever it is. So it's a yucky answer. So what do? You square it. And what do you get? A half. So so on your calc, you've got sine 45 squared, you get a half. But girls, I don't want sine 45 squared. I just want sine 45. So what's the square root of 1? And what's the square root of 2? Square root of 2. So you do the squared. So if you do sine 45 and it's a horrible answer, you square it. You say a half. You write that down, but then you go square root of 1 is 1, because 1 times 1 is 1. Square root of 2 is just square root of 2. You don't write down what it is. You just leave it as the exact value. Same with cos 45. If you do cos 45, you get a horrible answer, so you square it and you get a half. But now you square root it back. Square root of 1 is 1. Square root of 2 is square root of 2. The only time you'll simplify what the square root of something is if it's 1, because 1 times 1 is 1, the square root of 1 is 1. 2 times 2 is 4, the square root of 4 is 2. 3 times 3 is 9, The square root of 9 is 3. You would only change back if you got one of those answers. All right? And on the calc, tan 45 is 1. So on the calc, what do? If you get a decimal, you know, a non-terminating decimal, one that goes on forever, a decimal, square it, then square root it back in your head. Do you get what I'm saying? Then square root it in your head. Sorry, but that's what you do. Do you get what I'm saying? You're not allowed to just go and square it. So if you square it, you've got to square root it back. But you square root it back by just going square root of 1 is 1, square root of 2 is the square root of 2. Because on your calc, when you squared it, you got a half. Opposite of squaring, you know, squaring the little 2, opposite is square root. So that was the exact value for 45. Exact values for 30 degrees and 60 degrees. They are done together in a triangle with side length 2. You don't have to know. All right, so I'll show you how we do it. Equilateral triangle, side length 2, right? Tell me about the angles in that triangle. 60, good, 60. But you know what I'm going to do? I'm going to split this one in half with a right angle. See, girls, if you've got an isosceles triangle or an equilateral triangle and you draw a line from the top and it's vertical straight down to the bottom at right angles, then you split this angle up the top in half. And if I do split the angle up the top in half, that's called the apex of the triangle, the apex, like think of the summit and the mountain, the apex, all right? What would these angles here be? Good. But I'm not going to use both triangles. Now, if they're both 30 degrees, and that's 2, 2, 2, what do you think each of these down here is? If that's all 2, I've split it in half. Girls, if you fold an equilateral triangle in half, you know one side will sit on the other side. This is actually a line of symmetry, axis of symmetry. Remember, equilateral triangles have 3 axes of symmetry. That's why I'm allowed to put 30 degrees, 30 degrees. And now I'm allowed to say, well, if that's all 2, this is 1 and that's 1. All right, now that's a big mess. So I'm going to draw a triangle on its own. So I'm going to draw another triangle here. Take the left-hand side or the right-hand side. It doesn't matter which one you take. So if I do take part of it, what's this down here? I'm taking half of the triangle. This is 60. This is 30. What's this length? Good. And how would I work out the other side length? All right, so I'm going to call it x again. X squared equals, am I working out a shorter side or a longer side? So it's minus. So it's hypotenuse squared minus other shorter side squared. Yes, we can do x squared plus 1 squared equals 2 squared, but we know we're going to subtract. Okay? Always subtract when you're finding the shorter side. So therefore, what does x squared equal? What's 2 squared minus 1 squared? X squared is 3, so therefore x is the square root of 3. Girls, leave it. We don't, that is an exact value answer. So this is what I've got. 1, 2, and this side is actually root 3. I'm going to do the exact values for 60 degrees. I'm not going to put the 30 up here at the moment, but this would be 30 because it's a right angle triangle. Angle sum of a triangle is 180. If this is 90, these two add up to 90. So let's go. Sine of 60 degrees. Sine is opposite over hypotenuse. Now, don't get confused with sine rule. All right, this is a right angle triangle. Right angle triangles are used for Pythagoras or SOHCAHTOA. That's it. Okay? Let's go. Sine 60 is opposite over hypotenuse. What do you get? Root 3 on 2. Okay. Cos 60 is adjacent over hypotenuse. It's good. And tan of 60, yep, is root 3 over 1, which is root 3 over 1, which is root 3. Guys, have you got the diagram? I need to just make this. I'm hoping you can see that. To do these on your calc, you go sine 60. It's 0.866, whatever it is, not what you want. So you square it and you get 3/4, or some of you will get 0.75, but you know that's 3/4. So you write your 3/4 out if you want. Then you go square root, square root. I'm not allowed to just square it for the sake of it. I have to undo my square, which is square root. So I say square root of 3 is square root of 3, because it doesn't have an exact answer. Square root of 4 is 2. So that is root 3 on 2. The next one, cos of 60 on your calculator. If you get a nice answer, no need to square it. Cos of 60 is a half. Don't square it. It's nice. Do you get it? If it's nice, leave it. Like tan 45 was 1. You don't square it. You only square it if it's horrible. Tan 60 is 1.73, whatever it is. So it looks horrible, so square it, and you get 3. You can't just square it. Square root it back, square root of 3. Okay, I've drawn that triangle again down here with just the 30-degree angle. Let's go. Sine of 30 degrees. Yep. So on your calc, if you do sine 30 on your calc, you get a half. You don't need to square it. It's nice. Right, so this one is squared, then square root. This is nice. This one is square it, and then square root. Do you get what I'm doing? That one was nice. You leave it. Right? So sine 30 is a half. If you do it on your calculator, you get sine 30 is a half. Leave it. It's nice. Leave it. Got it? Next, cos of 30 degrees. Cos of 30, what have you got? Hello? Root 3 on 2. All right, let's do it on the calc. Cos of 30. It's horrible. 0.866. Horrible. Square it. And then, what do you get if you square it? 4. Square root it. What do you get? Root 3 over 2. And then you're going to square root it. Tan of 30. Tan of 30, not very nice. All right. Oh, sorry. On your thing, what do we get? 1 over square root of 3. Good. On your calc, what do you get? Tan of 30. Can't remember that one. Whatever it is, square it. You get 0.3. So, tan 30, horrible, square it. You get either a third or 0.33333, which is a third. Square root it back. Square root of 1 is 1. Square root of 3 is just the square root of 3. So, I want you to look at sine 60. Actually, no. We're summarizing them all now, a summary. Sine 30, get your calc out, it's a half. Good, don't touch it. Cos 30, get your calc out, it's horrible. You get 3/4 if you square it. Square root of 3, what's the square root of 2? Square root of 4, sorry, 2. Tan 30. Not nice. Square it. A third. Square root of 1 is 1. Square root of 3 is square root of 3. So, tan 30, not nice. Square it. You get a third. So, in your head, square root of the 1 is 1. Square root of 3 is just square root of 3. Do cos of 60. Not nice. Square it. You get 3/4. Oh, no. Oh, I'm sorry. I don't want to do cos 60. Can you move it down? I want to do sine first. Can you make it sine? I'm sorry. Shh. Sorry. I want to go sine cos tan. Okay. Okay, sine of 60 is not nice. Square root of 3, it's 3/4 if you square it. The square root of 3 over the square root of 4 is root 3 on 2. Sorry about that. So sine 60, not nice. You square it, you get 3/4. So square root of 3 is square root of 3, square root of 4 is 2. Cos 60 on your calculator is a half. Keep it. Tan 60 is not nice, 1.7, whatever it is. Square it, you get 3. Square root it back, you get the square root of 3. Right. Look at sine 30 and cos 60. They're the same. I'll show you why. Look at cos 30 and sine 60. They're the same. The reason is when you're looking at this right angle triangle, so when you look at this right angle triangle, I've got 1, root 3, 2, 60 degrees, 30 degrees. Sine of 30, is opposite over hypotenuse. It's a half. Notice that's the same as cos of 60 is also adjacent over hypotenuse, which is a half. So sine of 30 equals cos of 60. It's like you're looking at the triangle from the other angle. If we go cos of 30 is adjacent over a hypotenuse. It's root 3 on 2. But if I look at sine 60, that's opposite over hypotenuse. That's root 3 on 2. So the sine and the cos, 60 and 30 makes 90. Sine 30 equals cos 60. And cos 30 equals sine 60. As long as the two angles add up to 90 degrees. They're called complementary angles. And that will be tomorrow's lesson. We'll focus solely on that. Okay? But if you know sine 30 now, it means you automatically know sine cos 60. And if you know what cos 30 is, you automatically know sine 60. So I just learned sine 30, sine 60, and I know sine 60 is the same as cos 30, and I know sine 30 is the same as cos 60. And the way I remember the tan 30 and 60, you know how 30 is smaller than 60? Well, 1 on root 3 is smaller than root 3. So they've both got the root 3's, and the 30, 1 on root 3 is smaller than root 3. The 45s, can someone please calculate the 45-degree angle? If we look at sine 45, you get an answer that's not nice, so you square it and you get a half. Square root 1 is 1, square root of 2 is square root of 2. If you do cos 45 and you square it, you don't get a nice, if you do cos 45, you don't get a nice answer. Square it, you get a half. Square root of 1 is 1, square root of 2 is square root of 2. Now, let's look at this triangle. Sine 45 is 1 on root 2. Cos 45 is 1 on root 2. It doesn't matter. You get the same answer. All right? But what you're supposed to notice is that 45 plus 45 adds up to 90. Like sine 30 is the same as cos 60. Those two, 30 and 60, add up to 90. So sine 30 will equal cos 60. Cos 30 is equal to sine 60 because 30 and 60 makes 90. What does 45 and 45 add up to? All right, we'll spend more time on that tomorrow. Tan 45 is just 1 on 1, but if you do it on your calculator, it's 1, so you don't need to square it, and you don't need to square root it. Okay, notice those two are the same. Question 2b, it says find the exact value of sine squared 30. Now that means sine 30 times sine 30. Sine squared 30, actually, have you written it down? I think the better one to do is cos squared 30. Oh, it doesn't matter. Let's just do it. Isn't that sine 30 times sine 30? Now, what does sine 30 equal? I know you could do it on your calc if you wanted. So find the exact value of sine squared 30. What does sine 30 times sine 30 equal? What's sine 30 equal? So it's just a half times a half, which is a quarter. Good. So that's finding the exact value of sine squared 30. You know how you could have actually done that on your calc if you want. Sine 30 and square it. You'll get a quarter. Yeah.
Why isn't the square root after 30?
I don't think I'm recording. Yes, I am recording. Sine squared 30 means sine 30 times sine 30. They don't put the squared at the end, and you don't square the 30. It's just sine 30 times sine 30. That's how they write it. All right, I'll just show you. Sine squared 30 is the same as sine 30 all squared. All right? That's just how, see how that looks weird? This looks better. All right? So if you see sine squared 30, it means sine 30 squared. That's what it means. Or just sine 30 times sine 30. That's the notation they use. All right? All right, next question. Find the exact value of sine 45 cos 45. Sine 45 is, you can do it on your count, 1 on root 2. Cos 45 is the same. It's also 1 over root 2. Now what does this equal? 1 times 1 is 1. What's root 2 times root 2? Yeah, it's 2. Or it's the square root of 4, because whatever's under the square root signs, you multiply those. Square root of 2 times square root of 2, if you do it on, is the square root of 4, which is just 2. Do you want me to write square root of 4? All right, the next one. We okay? Cos 30. So girls, look, I will do it. Problem is we haven't done thirds. Square root of 2 times square root of 2. Whatever's under the square root signs, you multiply together and keep them under there. It's actually the square root of 4, which is 2. Year 10, exercise 2. Year 10, Mathscape. All right, one sec. So yeah, I've put it up here. Shh. Girls, I need to keep going. Cos 30, anyone know? What's cos 30? Square root of 3 on 2. If you're not sure, you do cos 30 and you square it, and you get 3/4. Sine 45 is 1 on root 2. What do you think the square root of 3 times just 1 is? Square root of 3. Now, I know we haven't done this. You can treat, you know that third like root 2, you can treat it just like an x. That 2 is not a square root. It's like 2 times root 2 is just 2 root 2. You just get rid of the multiplication symbol. What I'm going to do, tan of 60, what does that equal? What does tan of 60 equal? You can use your calc. Root 3. What's cos of 30? Root 3 on 2. What's tan of 45? 1. It's just 1. So, girls, tan of 60 times cos 30 times tan 45. You just write down what each one is. Now, square root of 3 times square root of 3, isn't that square root of 3 squared, which is, why don't we just do it like that? Isn't it the square root of 3 squared? And what's on the denominator? 2. What's the square root of 3 squared? 3 over 2. The answer is 1.5. Now, with these, I'm probably not going to get you to do these because you haven't learnt, well, we'll see. Tan of 60, what is it? Remember the 30 and the 60? Yep. Isn't tan 60 the bigger one? And tan of 30 is the smaller one. Okay, I'm just going to get you to do it like that. See how I've got numerator, denominator. Square root of 3, because it's not an exact number or can't be written as a fraction, it's called an irrational number. It's not rational, all right? So, you know, if I take any fraction and you know how you do equivalent fractions and you multiply the numerator and the denominator by the same thing? The only way I'm going to get rid of square root of 3 is to multiply it by square root of 3 again. So this is what I've got. I've got root 3 plus 1 on root 3, but I want to rationalize the denominator. I don't want any square roots on the bottom. Denominator, bottom. That's irrational. I don't want any thirds or square roots on the bottom. So what I'm going to do, I'm going to times not the first fraction, but the second fraction by square root of 3 over square root of 3. You know why? Because what does the square root of 3 over the square root of 3 equal? All right, so this is what I've got. I'll put that second fraction in brackets. So I've got square root of 3 here, which is okay, plus, with the second fraction 1 on root 3, I've just multiplied it by root 3 on root 3. I'll show you why. What's 1 times root 3? And what's root 3 times root 3? It's 3. Okay, now I'll just leave it like that for now. Do you know how I would make it a common denominator if I wanted? Times this one by 3 over 3. Do you get that? So if I want to write it with a common denominator, which is 3, the first fraction needs to be multiplied by 3 over 3. So I would have 3 root 3 plus root 3 over 3. Look, let's just leave it on this top line. One more, and that's still not finished. I really shouldn't be doing these until you've done surds. Let's just do this one. All right. All right, we'll do that one another day.